In this video, we are going to look at a couple examples of arc length and central angles. So first, an arc length is talking about the length of the outer part of the circle. So we're talking about whatever piece you have when we're looking at an angle. So for example, if I start and my angle goes right here, this piece into here would be my angle. The line here would be my radius. And then when we're talking about arc length, that's going to be this part right here, this curve. Okay, that is your arc length. Now when we're talking about it, we do have a formula that we use to try and help. And so with that, we are talking about this formula here, where your angle is equal to S. S is going to be your distance. So that's the curved part of your outer circle right here. So that's your S, and then R is your radius. Okay, so for example, let's say we have a distance of 200 centimeters, we're missing our radius, and we have an angle of 45 degrees. So the first thing that you have to do is you need to convert. So we're going to convert 45 degrees over to radians. Okay. So with this, we would have that 45 degrees times pi over 180 is going to give you pi over 4. So now in this case, once you've figured out your conversion, then we use our formula. So we have the angle is equal to S over R. When we're looking at our formula, the piece that's missing is the R, so we would go ahead and solve for it. So in this case, we have that R is going to be equal to S over my angle. My S here is going to be the 200 centimeters. My angle is pi over 4. So we would go ahead and do that. You can use your calculator to do it. But essentially you're going to come out with your measure, and so we would come out, in this case, my radius would be 254.65 centimeters. Now the reason we converted this over to decimals is because your direction said so, nearest hundredth. Okay. Now in this second line here, notice we're missing our distance, or the arc length. We have a radius and we have an angle, and my angle is already in radians. Therefore, in this case, we just simply have to start with our formula. So again, we know that my angle is equal to S over R. We're missing the S piece, so we solve for it. So in this case, my S is equal to my angle times R. So here we would look, my S is going to be my angle, which was 5 pi over 12. We're going to multiply that by your radius, which was 4.2 inches. In this case, we would then come out with your S being 5.50 inches. So that's just one example or way that you may see an arc length problem. Now this next example is more of a word problem, and so this is the other way, or the most popular way that you see arc length, is you see a word problem where you have to be able to deduce what's going on with your problem. So first and foremost, we're told that a circle with a diameter of 10 feet and an arc length of 20 feet long, essentially we want to know what the angle is in radians and what the angle is in degrees. Okay, so one of the things that you could do to try and help yourself stay straight is you could go ahead and draw yourself a picture. So here I'm going to go ahead and give myself a circle. So I've got my little circle here. Now of course you could just freehand it if you want, or obviously you can draw one like I did. And we want to input the information we have. One of that pieces of information is that we have a diameter. So let's go ahead and input a diameter. So we'll call that your diameter there. And so in this case we're told that your diameter is 10 feet. So here we're looking at your diameter being 10 feet. We can call this right here your center. And then we have, say, your radius. Alright, so in this case, here's a couple things that we know. So we know this piece right here is going to be my arc length. So this is my S, which we're told is 20 feet. This piece right here is my radius, and this is the piece that's missing. Okay. Now with this, because my diameter is 10 feet long, one of the things I know is I have a formula that allows me to go from diameter to radius. So my diameter is equal to twice the radius. So in this case, if my diameter is 10 equals twice the radius, divide everything by 2 and we get that 5 feet equals my radius. So in this case, my radius is going to be 5, leaving my angle as the piece that is missing. So in other words, what we're trying to do is figure out what is this angle here that with a radius of 5 will give us an arc length of 20. So we're going to go ahead and use the information we have and the formula that we have. So we have that my angle is going to equal S over R. Now in this case my angle is missing, so all I have to do is plug the information in that I have. So this is going to be my 20 feet divided by a radius of 5 feet. In this case we find out that my angle is going to be 4 radians. Now the other piece that we wanted is the degrees. So once you figure out your radians, we then have to convert my 4 radians into my degrees. So to do that, says we're going to take our 4 radians, so my 4 radians, and we're going to multiply that by 180 over pi. 180 is your degrees. In this case, you end up with 229.18 degrees, and if you look, this wants the nearest degree. So we're going to look at this, and on the other side of my decimal is a 1, therefore the nearest degree is going to be 229 degrees. Alright, the last type of equation you may see when dealing with arc length is one that deals with distance. So here we have, assuming that Columbia, South Carolina and Dayton Beach, Florida have the same longitude of 81 degrees west, we want to use a radius of 6,370 kilometers for the Earth and the following to find the distance between the two cities. Okay. Now with that, there's an important thing we have to remember, is that when we are dealing with anything that falls in the southern hemisphere, we have to automatically assume that that value is negative. So here we have South Carolina, which has a latitude of 34 degrees north, and then we have Daytona Beach, Florida, which has a latitude of 29.25 degrees north. Okay? So when we're talking about northern, southern hemispheres, we're looking, at specifically at that. We're looking at kind of your hemisphere breakup or idea between it. In this case, here's some information we know. We know that my radius was 6,370 kilometers. We also know that we are looking at having to do your South Carolina distance plus your Florida distance. Okay. Now, that being said, my Florida distance here is going to be considered the southern hemisphere. So in this case, when we do that, we have 34 degrees north. So this would be 34 degrees north. And we're going to subtract the 29.25 degrees north. In this case, this comes out with a change of 4.75 degrees. Now once we do that, we have to be able to use this to find our radians. So we're going to take this measure, we're going to go 4.75 degrees, and we're going to convert this into radians. We're going to multiply by pi over 180. And in this case, this becomes 0.0829, and this is radians. Okay. Now the last thing is we have to go ahead and answer our question. So we use our formula that our angle equals S over R. And in this case, we are trying to solve for the arc length. So we're going to rearrange it so that my arc length is equal to my radian times my angle. So in this case, my angle is 0.0829, and this is radians. And we're going to multiply that by our radius, which is 6,370 kilometers. So here my S is 528.10 kilometers. Alright, so that is kind of a snapshot with a few examples on working with your arc lengths. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed yourself, and I'll see you next time.